हेलो, गुड मॉर्निंग माय डियर स्टूडेंट्स, गुड मॉर्निंग। आज थोड़ा सा हम लोग दूसरा टॉपिक के बारे में डिस्कस करेंगे। थोड़ा सा हटके है, कुछ इनऑर्गेनिक रिएक्शंस हम डिस्कस करने वाला है। कैसे हम इनऑर्गेनिक रिएक्शन को इजी तरीके से सॉल्व कर सकते हैं, हाउ टू डू इनऑर्गेनिक रिएक्शंस विदाउट memorizing much. Is there any techniques? Based upon that, I am going to discuss few reactions. I hope this will help you. Let's concentrate. Suppose if I ask the first reaction, sodium hydroxide plus hydrochloric acid. Obviously, it is an acid-base reaction. You all know. Sodium hydroxide dissociate as Na plus and OH minus in aqueous solution. Hydrochloric acid also dissociate as H plus and Cl minus in aqueous solutions. Then what is happening? The product is obviously it is known to all, NaCl plus water. If you observe it minutely, what is happening here? This sodium becomes positive and OH is negative in water. Here hydrogen is positive and Cl is negative in water. Am I right? Okay. So therefore, what is happening, if you observe minutely, the positive of these combines with the negative of the others. Similarly, positive of these combines with the negative of the others. What is happening here? Double displacement reactions, ion exchange reaction. Am I right? Na plus combine with the Cl minus and H plus combines with the OH minus. Double displacement reaction. Here ion exchange is taking place and we are getting NaCl plus water. One is salt, other is water. We know acid react with base and give salt plus water. Very simple. This concept we learned in class 6, 7, I suppose. That reaction also we learned in class 7. Ion exchange reactions, double displacement reaction. Sure? But now if I ask the second reaction, sodium hydroxide plus carbon dioxide, what will be the product? No idea. Oh, why problem? What is the problem? What is the difference between this reaction and this reaction? We know carbon dioxide also is acid. Yes or no? Yes, carbon dioxide is acid. But here difference is that this is acid without H plus. Here, like I say, the HCl is acid and we can see the H plus. But here I am telling it is acid, but we cannot see H plus. That is the real problem. Therefore, you cannot visualize. Where is the H plus? How it is acid without H plus? That is the main problem. If you could have find H plus there, then also this reaction was as simple as the reaction number 1. But here in case of carbon dioxide, there is no H plus. We cannot say H plus here. If somehow we can generate H plus from carbon dioxide, then that reaction will be as easy as the first reaction. Am I right? Yes. Then how to find out the H plus from carbon dioxide? If carbon dioxide in gaseous phase, it is not acid. Carbon dioxide will act as acid only when you dissolve in water. Similarly, you know that hydrochloric acid, we say acid in aqueous medium, in water. But if I say HCl gaseous, it is not acid. HCl gaseous is not acid. Similarly, this carbon dioxide gaseous is not acid. Carbon dioxide when dissolved in water, what happens? You see, when you dissolve carbon dioxide in water, what will happen? This will give you H2CO3. Am I right? Carbon dioxide, simple addition of water. Carbon dioxide you dissolve in water, we are getting H2CO3. Now we know this H2CO3 can ionize as H plus and HCO3 minus. Therefore, in place of carbon dioxide, when you dissolve carbon dioxide in water, we may get H plus and H HCO3 minus. Therefore, in place of carbon dioxide, I can write as H plus and HCO3 minus. Could you follow my point? Carbon dioxide gaseous is not acid. Carbon dioxide when dissolved in water, it produces acid. What is the acid? Carbonic acid, H2CO3. This H2CO3 dissociate in the form of H plus and HCO3. Now, if you try to write the reaction sodium hydroxide plus H plus HCO3 minus, here also there is a positive, negative, here also there is a positive, negative. Now again, simple, just ion exchange. Positive of this combines with the negative of that. Negative of this combines with the positive of that. Therefore, what product we will get here? We will be getting NaHCO3 plus water. Could you follow it? Could you follow it? That means the problem was with the carbon dioxide. If we can convert carbon dioxide in the acidic form by dissolving in water, then again we can have positive and negative. Sodium hydroxide have positive, negative. Simple ion exchange, double displacement reactions, we can get the salt plus water. Therefore, here the product is now NaHCO3 plus water, same as the first reactions. Simply what we did, please try to understand that concept. If you know, understand that particular concept, rest all the questions you can solve easily. What I did, because this carbon dioxide not in ionized form, I convert this carbon dioxide in ionic form. How? By dissolving in water. What is dissolving in water? When you add in water, simple addition reaction. Simple addition. Carbon dioxide plus water, like X plus Y. A simple addition reaction. Both of them just combine. HCO3. We know this is the carbonic acid. This carbonic acid dissociate in the form of H plus and HCO3 minus. Therefore, I can say carbon dioxide can be written as H2CO3 in water. It is carbon dioxide only. It is in carbon dioxide in different forms. In aqueous form, it exists as H2CO3. That H2CO3 is nothing but H plus and HCO3 minus. Now, carbon dioxide can be written as H plus and HCO3 minus, positive, negative. Here also there is a positive, negative. Simple ion exchange, double displacement, and we are getting salt plus water. Clear? Okay, let's see the third reaction. Let's see the third reaction. Let's see the third reaction. Technique is same. Let's see the third reaction. Third reaction is what? In place of carbon dioxide is sulfur dioxide. In place of carbon dioxide, sulfur dioxide. Dissolve in water. Simple addition. What will happen? H2SO3. Am I right? Yes. Sorry. This H2SO3, again we can write as H plus HSO3 minus. Therefore, tell me the product. This will be your NaHSO3 plus water. Similarly, go for the third one. Fourth one, this is SO3 plus water. What will happen? It will be your H2SO4. This H2SO4 can be written as what? H plus and HSO4 minus. Therefore, what will be the final product? NaHSO4 plus water. Go for the next reactions. N2O3. Go for the next reaction. N2O3 plus water. What will happen? H2 N2O4. Am I right? दो हाइड्रोजन, दो नाइट्रोजन, यहाँ पे 3 ऑक्सीजन, यहाँ पे 1 ऑक्सीजन. 3 plus 1, that is 4. Here you see there is a common factor. What is the common factor? 2 is the common factor. Therefore, this I can write as twice HNO2. Twice HNO2. What is the name of the HNO2? This is called nitrous acid. This is called nitrous acid. Nitrous acid. This nitrous acid dissociate as H plus and NO2 minus. H plus and NO2 minus. Now we are having positive and negative. Here also we have a positive negative. Simple ion exchange. What will happen then? It will be your NaNO2 plus water. Clear? Very nice. Go for the next. Go for the next. What is the next question? N2O4. N2O4. Very simple. Simple addition of water. N2O4. Dissolve in water. We are getting H2, N2, H2, N2 and O5. दो हाइड्रोजन, दो नाइट्रोजन, यहाँ पे 4 ऑक्सीजन, यहाँ पे 1 ऑक्सीजन. Therefore total oxygen is 5. This H2N2O5 we can write as HNO2 and HNO3. Check it. दो हाइड्रोजन था, यहाँ पे एक हाइड्रोजन, यहाँ पे एक हाइड्रोजन, दो नाइट्रोजन था, यहाँ पे एक नाइट्रोजन, यहाँ पे एक नाइट्रोजन, 5 ऑक्सीजन था, यहाँ पे 2, यहाँ पे 3. Now this HNO2 is nothing but H plus NO2 minus. This HNO3 is nothing but H plus NO3 minus. Therefore here what we'll get? We'll get one product will get NaNO2, other product will get NaNO3 plus water, plus water, plus water. I am not balancing. Balancing part we can do later on. There is no problem. I am not balancing. Balancing part can be done. Okay, there are 2 sodiums. Therefore, here 2 sodium hydroxide will be required for that. You know that balancing part. I am just writing the product without balancing. Okay. Similarly, you can try the next one. N2O5. N2O5. What will happen? H2N2O6. Am I right? H2O2 O6. Am I right? Here there is a common factor. What is the common factor? 2 is the common factor. If I take the 2 common, I can write HNO3. This HNO3 can be written as H plus and NO3 minus. Therefore, what is happening here? This is the positive part, this is the negative part. And in case of sodium hydroxide, this is the positive part, this is the negative part. Ion exchange. Positive of sodium hydroxide, negative of this HNO3. A negative of sodium hydroxide, positive of the HNO3. Therefore, what product will get? You will be getting NaNO3 plus water. Clear? Yes. How easy it is? Do you want to do any necessity of the remembering? No. Only the technique. What is the technique? Just convert the oxides into their corresponding ionic form by dissolving in water. This corresponding oxide dissolve in water, convert into their corresponding ionic forms. Ionic means positive negative forms. Then simple ion exchange reaction. That will give the final product. Nothing to memorize. Yes, that is exactly. Then let us see these 3 reactions. Similar to that. But here little bit tricks is there for this particular 3 reactions. Now what is the tricks? Let me explain one, then other 2 will be easy for you. What is the tricks? We know we know phosphorus has 3 oxo acids. One is H3PO4, another is H3PO3, another is H3PO2. The most common oxo acids of phosphorus, there are 3: H3PO4, H3PO3, H3PO2. Yes, this phosphoric acid, phosphorus acid, hypophosphorus acid. There are 3 most common oxo acids of the phosphorus. Now, if we observe minutely their structure, I suppose one thing is common. What is the one thing is common? Hydrogen phosphorus ratio, I suppose it is 3:1. Hydrogen phosphorus ratio is 3:1. Hydrogen phosphorus ratio is 3:1. Am I right? If you observe these 3 compounds, one thing is obvious. Hydrogen phosphorus ratio is 3:1, 3:1, 3:1. Therefore, phosphorus and hydrogen atom must be in 3:1 ratio. Therefore, here how many phosphorus is there? If you talk about the first case, P2O3. How many phosphorus atom is there? 2 phosphorus atom is there. To maintain the ratio 3:1, how many hydrogen we should have? 6. Yes or no? ratio is 3:1. Hydrogen phosphorus ratio is 3:1 in all these three compounds. Therefore, here this P2O3, we have 2 phosphorus. To maintain the ratio 3:1, I need 6 hydrogen. That means I need to add 3 water molecule. In all other cases, we have added only 1 water molecule. In case of phosphorus, you should keep in mind, you need to add 3 water molecules, not 1 water molecules. Why? Because in case of oxyacids of phosphorus, hydrogen phosphorus ratio is your 3:1. Therefore, to maintain the ratio 3:1, here there are 2 phosphorus, we require 6 hydrogen. That means we need to add 3 water molecules. That is the difference with the rest of the reactions. In case of phosphorus, how many water molecule you need to add? 3 water molecule. Clear? Yes. Therefore, you see, we will be getting here 6 hydrogen, 3 into 2, 6 hydrogen, 2 phosphorus, 3 into 1, 1 oxygen, 3 plus 3, 6 oxygens. Here there is a 2 is a common factor. Therefore, I can write this as twice H3PO3. 2 I am taking as a common, H3PO3. This H3PO3 can be written as H plus and H2PO3 minus. We can write like this. Now we are getting in their ionic form, one is positive, other is negative. Here this is positive, this is negative. Again same ion exchange reaction. Positive of this combines with the negative of this. Therefore, we are getting NaH2PO3, and positive of this combined with the negative of that plus water. I am not doing the balancing. Okay. Could you follow my point? Similarly, if you talk about the next one, what is the next one? P2O4. Again, I told you in case of phosphorus, how many water you need to add? Always 3, because hydrogen phosphorus ratio is 3:1. That point you should keep in mind. Rest other cases we have added only 1 water molecule. Only in case of phosphorus, that is the only case where we need to add 3 water molecule, not 1 water molecule. Therefore, here also we will add the 3 water molecule. Then what we will get? We will get 6 hydrogen, 2 phosphorus, and we will get 7 oxygen here, I suppose. Am I right? 4 plus 3, we will get 7 oxygen. This compound we can write as like this: H3PO4 and H3PO3. Check it. There are totally 6 hydrogen. Here 3, 6. Totally there are 2 phosphorus. Here 1 phosphorus, here 1 phosphorus. Totally there are 7 oxygen. Here 4, here 3. This compound is nothing but H plus H2PO4 minus. This compound is nothing but H plus H2PO3 minus. Again we are getting the corresponding ionic form. Then simple ion exchange. Therefore, what we will get? We will be getting here NaH2PO4 plus NaH2PO3 plus water. Similarly, you can solve the last reaction. Can you try? Okay, you try. You try at your own. I hope you got the answer. Yes. Just let me show you the final products. P2O5, again 3 water molecules. Therefore, what we will get? 6 hydrogen, 2 phosphorus, 5 plus 3, 8 oxygen. Here there is a 2 as a common factor. Therefore, I can write this twice H3PO4. This H3PO4 I can write H plus H2PO4 minus. Therefore, final product is here NaH2PO4 plus water. Here there is only 10 reactions. Similarly, we can solve another 30 reaction. I hope you could follow that. Only simple techniques, 2-3 points we should keep in mind. One is the addition of water. Another thing is that in case of phosphorus, we need to add 3 water molecules. In case of all the phosphorus oxides, we need to add the 3 water molecules. Why? Because in case of oxyacids of the phosphorus, the hydrogen phosphorus ratio is 3:1. These 2 points, addition of water and addition of water in case of phosphorus oxides is 3, not 1. Then convert into ionic forms, then ion exchange reaction. Similarly, we can do another 30 reactions without memorizing much. If I get chance, I will give another class on the rest of the reactions. Okay, thank you. Good luck. Good luck.